This is Brian Putt. Previously in a video, I developed a model around the opportunity to hold a concert for a grad night. In this video, we are going to continue with that model and do some additional modeling, graphing, and analysis to say what the appropriate price for the ticket should be.
Here is our model. As you recall, we had uncertainties of how many attendees would participate. 500, 2,000, or 3,000 in a triangular distribution. We had the cost of the ticket as an uncertainty, fixed costs, and variable costs. These were then used in a deterministic model, calculating revenue, fixed cost, variable cost, and profit. And then we calculated the statistics for these variables down here, EV, P10, 50, and 90. And we had distributions shown here as histograms. What we want to do now is to add a cumulative distribution function for profit. And we're going to do that by calculating the percentiles over a range and then plotting them. Let's add a worksheet, and let's call this cum probability. And then over here, I'm going to put some percentiles. Well, I'm going to start off with 0.002, then 0.01, and then we'll go every 1 percentile here for a while. I'm going to take that and then I'll just drag that down. It should just copy down. I need about 100 of these things. There we go. Perfect. Get rid of those and put in a 0.998. That'll make it symmetrical. The 0.998 and the 0.002 will pick up the very tails. Now, how do we get the percentiles? So this is the percentiles. Now, this is going to be, let's just go pick up from the PM table a title here of D revenue. Now, what I'd like to do is to have a function here that copies across, because I have a multitude of variables I'm going to have. So we will we're going to do it this way. I'm going to do this equal percentile exe. Now this is where it gets a little bit tricky. Because these are range names, I'm going to actually specify this first cell here, shift and down, comma, and then this percentile. And then I'm going to edit this equation. So this doesn't really want to start at C3, it wants to start at C4. But if I'd started at C4, it would have put a range name in there, and I didn't want the range name. I also want the 4 to be consistently I want that range to start at 4, and I want this to end at 1003. And over here, I always want to use the a function. We can also get, for simplicity, we can also get rid of that worksheet name. So now I have a function that will copy down, and I can copy there and go across here, here, and here. I now have the cumulative distribution function for each of my random variables, and if I add additional random variables, I can just copy those across as well. So now we want to do a plot of this cumulative distribution function. There's lots of ways to do this. The way I like to do it is I like to pick on the y-axis, so I'm going to say shift and down, and I'll go to insert. I'm going to insert an XY graph, and I'm going to do one of these, scatter with straight lines. And then I need to tell it the X data, so I'll edit this, edit. The X data is my profit. So we're just going to do profit right now, and down. And I can give it a title here equal to this. And there should be my graph. Except it's way down here. Okay, I'm going to move it to the top. Control X, move it to go up to the top. Control Y. Let's get this fixed up. Format the axis to 1, and then for the numbers we'll make it percentage, and we only need 0 decimal points. Does that look okay? Let's bring that over let's copy that over to our model, so we'll have that available. There's our histogram of profit, and then there's our cumulative distribution function. The next thing we want to do is to change our ticket price, cost per ticket, from a uncertainty, which it is now, because it depends upon these three ranges and this random number, and make it a decision. So what I'm going to do is I'm going to add a few rows up here, and I'm just going to move this, Control X, and I'll just put it up here, and we'll call these decisions, and let's call that $50. Okay, so now what I've done is to change this profit to reflect only $50. And if I looked at if I was to look at this cost per ticket, it would only be $50. It doesn't change, right? It's a solid 50. So let's split my screen, and we will see what is the best ticket price. So at $50, I have an expected profit of 88. And if I went down to 45, it drops to 79. If I went up to 55, it goes to 79. If I went to 60, it goes to 106. And if I went to 200, it goes to 361. What is missing in this model? Let's go back over to our influence diagram. And we said that the price of the tickets impacts the revenue, and the tickets sold impact the revenue. What we didn't say was that the ticket price also impacts the number of tickets sold. When the price of the tickets get too high, the number of tickets sold goes down. So back to our model. What we need to do is we need to add in a market demand. So let's think about how we're going to do that. So this is the demand for tickets. And let's think in terms of the min and the most likely and the max again. And let's ask the question, when the price of the ticket is $40, what is the minimum, most likely, and max number of tickets we would sell? Let's assume that that is 2,000, 3,000, and 3,500. And if the price of the ticket was 60, I'm just going to bracket our $50. 250, 500, and 2,000. So I now have a range. So let's put this back to our 50. I want to do one other thing before I move on to the next step. I want to store this distribution here, because that's kind of our reference. That's kind of where we started. We thought we were going to sell it for about $50. So let's go over to our Cumprob, and here's our profits function. We'll just take this, highlight that whole thing, copy it, And then I'm just going to go over here and I'll paste values, styles, and this is our reference profit. $50 is the price. Okay. All right, now where are we going to go from here? Well, we need to, when we pick a price here, this is going to impact our attendance. See, these are no more. We don't need any of those anymore. Okay, because that's now we've made demand, the cost of the ticket, a decision. It doesn't have any uncertainties. Now there's a function called trend. And what I'm going to do is say the minimum is the linear interpolation or extrapolation between a price of $40 and a price of $60. Okay. Let me show you how this works. So down here, number of attendees, we're going to type equals trend. And you'll see that what it wants for inputs are the known y's, the known x's, and then the new x. In our case, the new x is the cost of the ticket, and the y are the number of attendees. So we're going to put in the number of attendees. We're going to put in the price of the ticket, and we'll put in our current price, and we'll hit the end the function, and we get an answer. So we said $50, which is right in the middle of these two things, and so it's right between 2,000 and 250. So we can fix this equation up so we can copy it across. That's an F4 to hard code that one, and the E's are what we want to fix on that, and then the other ones copy across. We can double check our answer. 1750 looks like the average of this, and 2750 looks like the average of this, so this looks right. So what I've done is incorporated a probabilistic demand function into our model based on the price of the ticket. So now let's go look at our new demand function, our new profit function. We now have a profit of 90.9. Let's split our screen here again. And this way, I'll tell you what, we just look at this way, and then we'll go up here. And now we can, I'll tell you what I'm going to do. I'm going to take this, I'm going to put the cost of the ticket right here as an output, if you will. And I'm going to copy this over to here as values. Where's my values? There it is. There's my values. Okay. So now let's put in 45. And the price went up to, or the cost, profit went up to 103. Oh, that's good. So why don't we go $40? 110, even better. I'm just storing these so we have a better way of comparing them. Well, let's keep going. 35, 113. Wow. $30. 110. Oh, that went down, didn't it? So at $40 it was 110, at 35 it was 113, and at $30 was 110 again. So it's going up and then down. Well, what is the optimum price? How are we going to do that? We can do it actually fairly easily. What we need to use is the function called solver in Excel. And solver, if it's not there, you may have to add it in as an add-in. So I'll leave that to you to figure out if you need to add it in. So we'll go over here to solver, and we need to say set an objective function. Well, my objective function is the profit, my expected value profit. And I want to change my cost of the ticket. And let's see, I want to maximize my profit. I think that's all I need. Let's see what happens. It found an answer. It says OK. It says the solver has converged to the current solution. All constraints are satisfied. Well, we didn't have any constraints. So it says the optimum price is $34.75. Let's just store that over here. And now what we could do is we could plot our profit as a function of, and since these are not ordered yet, I will select the data, edit, like that. Okay, that's not what I expected. So let's change the scale to be 80,000. See if that helps us. It does not. See what happened up here is the two are not aligned. There we go. See, that looks better. There we go. So we can see we have a function that goes up and then back down, and it would continue to go down if we did other revenues. Now there's one more step here that we want to do, and that is we would like to plot the distribution. Let's move this someplace else. Make my screen a little bit smaller. Oh, that's too small. There we go. What I want to do is plot the distribution of our new profit versus our reference. Remember, we saved that before. So let's take this graph and we'll go to Design, select Data, and we're going to add, and this is going to be our reference profit. We could also point to that title we put in. The X values are over here on the Cum prob, and the X values are right here, and the Y values are over here. Okay. Wow! Look at that. Here is the, let's add a legend. Say, oh, we have to finish saying, say okay. I'm going to add a legend here. Add a legend. So what we see is our profit with our optimum price is over here. This is the 30. What is it? The price is $34.75. And over here was our $50. See, it's $34.75. We actually have very little downside, or a lot more upside. We don't lose much of this upside here. So this is really a much better price for our tickets. So I think that completes our study of the concert. We know that we should be charging $34.75 Maybe we want to charge $34.99 for our concert, and we hope to raise a lot of revenue. Hope you found this video interesting. If you want to learn more about SIPmath, please visit probabilitymanagement.org. There are videos on the site, and you can go to the various tabs that are highlighted below. SIPmath, download the free tools, and models. Another thing you can do is go look at the book The Flaw of Averages by Sam Savage. It has lots of good examples, stories. Really encourage you to review that book. Finally, you can contact me through LinkedIn, and I can send you some additional material. Thank you again for watching.